Welding. Today we will discuss the welding process, which is one of the very important joining process, and it is a permanent joining process, as we all know. The main objective of this class is to give an outline about the welding processes and the underlying principles during welding. Welding can be defined as this process of joining two similar or dissimilar metals by fusion, with or without the application of pressure and with or without the use of filler metal. Heat may be obtained from any source, heat source. For example, blacksmith's fire, electric arc, or electrical resistance, or even by chemical reactions. If the process of joining two metals with a filler metal of the same filler rod of the same metal, it is called autogeneous welding. And the other case, if you are using a dissimilar metals by using filler rod of any other metal or other than the parent metals, it is called heterogeneous welding. Another important term is the weldability related to welding, which is the capacity to be welded into a specific structure that has certain properties and characteristics and will satisfactorily meet service requirements. For getting a proper weld, selecting the material of the electrode and finding out the combination, a thorough knowledge of phase diagram is essential. At what temperature it will melt and what temperature it will solidify, start solidify and complete solidification time. All these things you should know. Factors such as strength, toughness, ductility, elastic modulus and melting point, mismatch in thermal expansion, that is coefficient of thermal expansion, surface tension characteristics, corrosion resistance, all these factors are important. Moisture and oxide medium causes porosity and fusion respectively. Weldability, the factors affecting weldability: welding process, base metal, filler metal and surface condition. And in a welded joint, we can see three distinct zones, namely the base metal, heat affected zone and weld metal. Among this, the heat affected zone is very interesting topic and it needs more study for getting a correct welding. Metallurgy and properties of second and third zone depend on the strength of the welded joint. And the heat affected zone can be like this, which is indicated in the figure. The original structure is there, then the heat affected zone, that is in between the fusion zone and original structure, that is the area where the heat is affected. Due to the heat generated during welding, the structure of the base metal is affected at certain distance. This area, this zone is called heat affected zone. Also we can see the temperature difference, that is the original parent base metal at atmospheric temperature to the welding point, that is the midpoint of weld, the maximum temperature is there, and uniformly the temperature is reduced to atmosphere at the parent metal. The grain structure, the grain growth, you can see the grain growth is always parallel to the direction of heat transfer. In the figure, it is figure A, a deep weld is shown, and at figure B, a shallow weld is shown. In both these, the direction of heat flow is different, and accordingly, this grain structure or the grain growth, which is perpendicular to the, which is parallel to the heat flow direction. Solidification of weld metal is more or less similar to the castings because the structure obtained is a cast structure, and the grain structure and size of each grains depends on the alloy combinations, and it is cooled from one end to the other, that is the base metal to the top, as the temperature indicated on this diagram. Here we can see the highest temperature is here and lowest temperature is here. So after on the first pass, the molten electrode fills this area and the heat is transferred to the base metal and it starts solidification. After that, it gradually fills at different passes, and finally solidifying area is this one. So accordingly, the structure, the hardness, everything is changed. We will discuss now. Now here we can see the weld bead and its hardness which is, you can see here the melt zone, and this is the solidified zone, and in between the heat affected zone, it is for a 1 millimeter length which is zoom, and it is 0.1 millimeter, and the difference in hardness, we can see the micro hardness across the weld varies like this. The lower hardness of the base weld bead compared to the base metal. The you can see here 146 and here 355. This is the hardness. So that is the hardness here. It will be more clear in this picture. You can see the hardness here, the 145 value. That is on the last solidifying area. It will become more soft. The material will become more soft, and here it will be more hard. Here the filler is most ductile, however with poor strength. Whereas in this bottom area, here the filler is most brittle, however with great strength. So the strength is very less here in this area, and here the strength is more. Now we look into the heat affected zone, where the temperature is affected during welding process. In the metal itself, a part of the solidified metal, the parent metal, heat affected zone is there. It is spread into the base metal area or little bit. The properties depending upon the width of the heat affected zone is rate of heat input and cooling, temperature to which the zone was raised, original grain size, grain orientation, degree of prior cold or hot condition of the workpiece. The strength and hardness depend partly on how original strength and hardness of the base metal was developed prior to the welding. And here a corrosion at the weld area is indicated. When it is exposed to a caustic solution, we can see the weld line is at the center of the photograph, and it is a microscopic view from scanning electron micrograph, and we can see the corrosion area and intergranular corrosion taking place here. It is a stainless steel welded tube, and after corrosion we can see the grains more clearly. Types of welding. Welding processes are of many types depending upon the various parameters. Pressure or forge welding or solid state welding. In this process, solid state welding process, no filler material is used. It may be hot welding process or cold welding process. Hot welding process is familiar to everybody. Blacksmith forge welding, resistance welding, butt flash, percussion, upset, projection weldings, friction welding, etc. come under the hot pressure welding process. Next classification is non-pressure or fusion welding process. This is the two broad classifications of welding process. Non-pressure or fusion welding processes can be again subdivided into the electric arc welding, gas welding processes, and chemical reaction welding processes. Electric arc welding have another subdivisions such as atomic hydrogen welding, carbon arc welding, metal arc welding, submerged arc welding, inert gas welding, and stud arc welding. TIG and MIG welding is familiar to you by name because it is gaining more importance in today's scenario. Inert gas welding is this TIG and MIG welding comes under inert gas welding processes. Gas welding, obviously oxyacetylene gas welding is most familiar and generally used. The acetylene, in the space of acetylene, you can use any gaseous fuel with oxygen and the gas welding taking place. Chemical reaction. Thermic welding is one example of chemical, the welding process by which uses the heat from chemical reaction is used for melting the parent metals and getting the joint. Types of welded joints. Depending upon the joints, the welded joints can be classified into lap joint, butt joint, corner joint, edge joint, T-joint, etc. And among this, the lap joint, corner joint, edge joint, and T-joint are also known as fillet welded joints. Butt joint may be single V butt joint, single U butt joint, double V butt joint, double U butt joint, or square butt. Whereas lap joint may be the single transverse, double transverse, and parallel lap joints. Welding positions: flat position, horizontal position, vertical position, and overhead position, or underwater welding process is there, no? Depending upon the XYZ direction of welding, you can see like this: flat, horizontal, vertical, or overhead positions. Weld quality is another important thing we have to make into focus, because if there is defects, it will not serve the purpose. So the different welding defects includes the cracks, cavities, solid inclusions, incomplete fusion, imperfect shape, miscellaneous defects such as arc, strike, and excessive spatter over the surface, which will affect the appearance of the weld itself. And so this a sound weld means it should be free from defects. Also, the defect namely includes the residual stresses and distortions. Residual stresses in this sense, the stresses after welding process, there is certain stresses are there made due to the process, uneven heating and cooling of the workpieces or like that. The heat sink can be used for proper uniform cooling of the work area. Then the preheating can be utilized to resist the residual stresses. Preheating of the workpiece before welding process, we can heat the area by using oxyacetylene flame or like that, and then we can reduce the residual stresses which may come on that area. No? Stress relief heat treatments is another process which is done to remove the residual stresses which is embedded into the joint while after welding process. Then the visual inspection, we can inspect the welding processes by visual inspection, which is the most common process. Then we can identify the cracks on the surfaces or warpage of the parent pieces or dimensional inaccuracy we can easily identify by visual inspection. And the limitations of this process includes only surface defects are detectable by visual inspection, inside the defects inside which cannot be predicted, and it is the major limitation of this process, which can be identified by using non-destructive testing processes such as X-ray or dye penetrant test. We can identify that one, but normally in the normal that requires extra setup for checking here, but normally on visual inspection it cannot be identified. That is the main limitation of this one. Then the testing of welded joints may be destructive testing or non-destructive testing process. In the destructive testing process, the joint becomes non-usable because the mechanical and metallurgical tests are carried out. Mechanical tests such as cutting of the joint to see the cross section whether it is perfect or not, which after that we can identify the defects, but it becomes non-serviceable. Then in metallurgical tests we can check the composition inside the joint like that. But in these tests, after carrying out these tests, the joint becomes non-usable. In non-destructive testing, we can test the piece, and after, if there is no defect, we can use that one in the intended purpose. Dye penetrant test is one test. The magnetic particle testing, ultrasonic inspection, and radiographic inspection tests, which uses X-rays or gamma radiation. These are the non-destructive testing processes. In dye penetrant testing process, a fluorescent penetrant is applied over the surface, and it is allowed to penetrate into the small cracks which may be there on the surface. And after that one, we can remove the dye from the surface. Then some powder is applied to absorb the dyes which are there in the cracks if it is there. If there is some crack, the dyes will flow into that one, and when we are applying this powder, that will come up, that will be the dye will be absorbed by the powder particles. Then easily we can identify there is some crack. Magnetic particle testing. In the magnetic particle testing, iron filings sprinkled over the surface, and under the magnetic field, if there is some crack inside the surface, then it will form a line over which the edges of the crack are polarized. Due to that, the magnetic particles will be attracted to the edges of this crack and easily identified. Ultrasonic test, high frequency sound waves directed through specimen. So the discontinuity is detected by loss in sound transmission, which can be sensed by suitable sensors and easily identified. Next is radiograph test, in which X-ray or gamma radiations are used, and the photographic film on which these rays fall. By penetrating through the joint, we can identify any internal cracks. Now, okay, this is about the welding processes, and if there is any doubt, you can ask it. Okay, thank you.